Thank you, Kendall. Now, as the Department of Energy prepares to issue a request for proposals to build up to 9,600 megawatts of nuclear power generation capacity, a better understanding about localization, readiness and fabrication code opportunities is critical for all service providers who are going to be involved in this process. Now, with a construction period of 10 years per nuclear plant and a fleet build program lasting more than 20 years, local suppliers must maximize the impact of localization to stimulate the local economy in delivery of the much anticipated nuclear program. Now, to unpack the story further in our studios, we are joined by John Fletcher. He's a nuclear localization specialist at Eon Consulting. John, a very good morning to you and welcome.
Good morning. Thank you. It's nice to be here.
First and foremost, tell us about localization. What is it all about and why is it important?
So in the context of the nuclear new build, the government will be spending a vast amount of money, and we want to ensure that we maximize that portion of that spending that we can in South Africa for the benefit of our country. And in the process, we develop a lot of skills, a lot of knowledge, a lot of competence, there are all sorts of benefits, spin-offs to having a large localization program. And it's certainly very important, and that's why we're here, because we're very passionate about, I guess, unlocking and unpacking what it is, what localization will mean to local industry and how they can participate.
Now, localization refers to local is lekker. Does that indicate that all infrastructure will be built here in South Africa?
So you need to understand that a nuclear plant has a nuclear island, which is the section, the nuclear section, the reactor, the steam generator, the pressure vessels, and so on, which you always see in those domed, in the pictures of nuclear plants in the dome part. That typically will be supplied by the vendor, the foreign suppliers. That's the high-grade, high-safety related components. But the rest of the plant, which we would call the balance of plant and all the civil works, there's a large portion of components that are non-nuclear that can be supplied by the local industry. And that's our message, is that local industry needs to understand what it is that are required from components that can be supplied by local suppliers without too much effort from their side in getting all sorts of sophisticated quality management accreditations and the likes. Many years ago, we told suppliers that if you want to participate in a nuclear new build, you need to have yourself nuclear qualified or nuclear accredited, and everybody knows that's sophisticated, that costs a lot of money, etc., etc. And I think we're scared of suppliers, and so our message today is that, in fact, up to 60% of the expenditure of a new build can be spent locally if you get it right. Not so easy. Typically, I can give you an example. When Coburg was built in the 70s, there was not a very strong localization requirement, but they achieved, I think it was, the final number was 43% of the value of the plant was sourced locally. And that was, the term they use is, it happened naturally. So they sourced what they could, and it ended up at 43%. Now, so we can say the same thing for this new build. We should quite easily be able to achieve naturally, but if we want to push it up higher, there's a bit of effort. So industry needs to understand what it is they need to do to, inverted commas, up their game to be able to participate and fully get what they can out of the spend. So
the potential is there to keep it localized. Yes. But what about the human resource that go with a nuclear plant? Some people would suggest that we don't have that type of resource here.
So, I mean, from a fabrication, from a component supplying perspective, so for fabrication products, those are suppliers. But we also need to, I entirely agree with you that I think, and typically, if you look at documents that are issued by the International Atomic Energy Agency on things like localization, you need to start now with training programs. So as soon as we have sight, when the government or the DOE releases the bid and we have sight as to what is in there regarding their localization requirements, then we can start the process of saying, listen guys, we've got 5 years or 6 years, whatever it is, to be ready. Let's get going now. These are the type of skills we're going to need because they can be sourced locally and they can be used locally. Big programs. So it has to be a national thing. It can't just be the individual suppliers gearing. It has to be a policy from government side. And I do know that government is very strong on localization. So I'm hoping there will be and I'm aware of at least 2 studies that were put out to tender by the DOE to look at different localization models and what can be localized and how much can be localized and how soon and how you phase it over the different number of units and so on. So there's a lot of knowledge out there. We just need to get details so that we can then figure out how we're going to do it.
Yeah. Now, it takes about 10 years to construct a nuclear plant. And of course, if you want a fleet build program, that could take about 20 years. Why does it take so long and why is that important to have?
So typically, a new plant like that, there's a lot of regulatory and licensing activities, and of course environmental impact assessment. There's paperwork that needs to be completed before you can turn the first sod on the ground. And the licensing process will take a while. The review of the environmental impact assessment will take a while. The site approval license will take a while. There's a lot of work that has to be done before the actual commencement of the construction can start. The first plant will probably take the longest. Thereafter, if it's a fleet and it's similar plants, then we learn as we go, so we should get smarter and it should happen more quickly. The phasing is the demand on the grid. Can the grid absorb the amount of energy you're putting into it? And secondly, the cost. So the more you spend over a shorter period, the more money you've got to fork out. So if you want to phase it over a longer period, it's possibly more affordable. But then again, if you need the power sooner, it's this whole balancing act.
Now, some would suggest that by now, when Kusile is up and Medupi is up and we have all the other plants going, that we should have enough power in the country. Why do we need nuclear? And is that a viable proposition?
So indeed, the short-term view is by 2018, possibly we should be okay. We should have a surplus, possibly. But that's not going to last, because we know that the fossil stations that we have are rapidly getting to the end of their useful life, and refurbishments are going to be needed. It's old technology. They're very dirty. They put out large volumes of CO2. They're not good for the greenhouse gas. And we as nuclear say, well, nuclear is the new low carbon fuel that we can use, or power supply, power generation that we can use to radically, drastically reduce carbon emissions into the atmosphere. So as we then start building and phasing in, as we've said, it's a long, slow process, and the process is driven by the demand. So they take a view when they look at the integrated resource plan that is put out by the DOE. It says we have a high road and a low road, an intermediate road as to what we anticipate the GDP growth is going to be in the country. For that, we need to match the power supply. And so there are different curves, and at the moment the curve has actually been incredibly low. The demand hasn't been what was expected. But if we get the power up and running, when Medupi and Kusile are running and Gula is halfway there already, then there's going to be an increased demand for power. And the big thing about putting in phasing over a 20-year period, as we bring in the nuclear, so we can phase out and mothball the dirty, smelly, coal-fired power stations, which essentially have served us very well, but become increasingly more expensive to run, as we know from a maintenance perspective.
Now, if we look back at the nuclear power station we got in Cape Town, that's been running for years. I think there was only one problem with a little screw in there.
A bolt in the generator.
Yes.
So it has a very good record, availability record. It's above 90%. That it operates. The time that it operates is above 90%, which is incredible. But that's what nuclear power plants are about. They're very reliable because the technology is it's such high tech. Everything is so carefully monitored. They can't afford anything to go wrong ever. So there's systems upon systems upon systems to make sure the plant is safe.
What are the benefits? Are there job creation possibilities? And are there any offsets from this particular project?
So massive, and that's the point of localization. If there were no localization and we just paid a foreign vendor to come in, build the plant, pay suppliers from their local country, then they would come in, do it and leave, and there would be absolutely no benefit to the local economy whatsoever, other than a reliable new source of power. So we want to follow the other route and actually make sure that the country benefits massively, not only from the increased power generation, but from the jobs, the skills. Countries need large engineering and or science projects. It's proven all over the world. We've got the SKA, that is absolutely fantastic. The nuclear new build will be another, that type of thing. The number of students that will get bursaries, that type of thing, the training that's going to be done, we need it. The country certainly needs it. It's a big stimulus.
And what about job creation? I mean, there's a lot of people that says, you know, there is a shortage of jobs. Will there be job creation, especially for people that are skilled in the art of maybe welding, for that matter?
Well, certainly. So that's the point. I mean, the opportunity there will be to lift your skills. So welding on a nuclear plant is the ultimate type of welding. If you're a welder and you want to aspire to heights, that's what you would want to do. You want to weld inside that concrete dome on the nuclear supply system. That's on the Class 1 components. For that, you've got to be top-notch welder. And you could get there. So as we say, if there's a fleet and it takes 20 years, if you start your training now and you learn on the first plant, by the 5th or the 6th or the 7th plant, you are there and you've got an incredible skill. The sad thing is that it always ends. So Medupi and Kusile, we're talking to some civil contractors that work there, and the civil works is completed, and there's a lot of skills that were built up and a lot of knowledge. Those people now are drifting away and there's nothing for them to go to. We need to capitalize on that and move them onto nuclear as soon as possible to continue the process. So, you know, you don't want these interruptions.
John, just briefly, we just had the president there in terms of the arms steel procurement report that came out with no adverse findings. A lot of money being spent on that particular report and, of course, that particular program. What's your view on this, and would that be maybe have an impact on the nuclear build program?
So, you know, there's been a lot of talk, speculation in the press regarding that if we did embark upon this program, there would be enormous levels of bribery and corruption, and money would go into the wrong hands, and so on and so forth. I guess what the arms report is saying is that we have a chance there that in fact it's not as bad as it sounded, and that, you know, but the procurement process is so solid. You know, I don't see how you easily can bypass and actually, you know, the process is not flawed. It's so open and so transparent, and it's such a big, technically complex. The bid documents will be a pile of documents this high that people have to go through. Most people not even going to understand what is written in there. You know? So I think we have a good chance of getting it right.
Now, we're running out of time, but I need to ask this question. International vendors have already started engaging local partners. Who is winning this bid?
So, boy, would we love to know. You know, we don't have a preference. So we don't have a preference for the technology. So whether it's Rosatom or the Chinese or the Koreans, the technology is very similar. It's generation 3 technology. It's very similar. They have reference plants that are operating. So we will not be buying something that is a first of a kind that hasn't proven itself somewhere. So technically, from a technology perspective, it doesn't really matter who the supplier is. It's going to be about the affordability. And what they were saying at a meeting I was at the other day, this is a long-term relationship. You've got to take your time to get it right, because it's a 20 or a 30 or a 40 or a 50-year relationship. Remember, the nuclear plant is designed for 40 years. They do lifetime extensions to 60 years. In America, they're going for 80 years. So you can have a relationship with that vendor for possibly 80 years, supplying fuel, reprocessing fuel, giving you spares, and so on. So you've got to take a long time and think very carefully about who you're going to appoint, because it's a lifetime commitment. So we'd love to know, but we give them time.
Yes, John, thank you so much for joining us here in studio. That was John Fletcher. He's a nuclear localization specialist at Eon Consulting, giving us the rundown there. Now, as I said, it's a long-term investment and relationship. 40 years from now, you'll see me and him talking about this from then. So you have to stay tuned to get more on the nuclear build program. Let's now